Hey guys, Horik here. Here's the practice quiz for transformations, our last unit. It's fairly short, so this shouldn't be too long a video. Um, so we have two graphing problems on here, and you look at this function, and you should be able to kind of recognize the parent function is y equals, or f of x equals x squared. So what are we doing to x squared? Well, first, inside the parentheses here, to make this equal to 0, in other words, our vertex for this function is equal to 0, 0. So if we take that point 0, 0, and this is a parabola, and I'm sure you guys kind of, this is y equals x squared. 1, and then it goes up to 3, basically about like that. And it starts at 0, 0. We're going to move the vertex right 3. Scroll this down a little bit, just put this in here right now. We're going to go right 3, and then we're going to stretch it by a factor of 2. So in other words, it's going to go up twice as fast. And stretch, I'll just put stretch 2. And then we're going to flip it over the x-axis because it's a negative 2. Flip over x. And then finally, the last step would be to raise the graph up 4. So we're doing a lot with this graph. So our vertex, to make it 0, 0, we had to put in 3 for x. So we're actually going to be moving positive 3. So we're going to be moving to the right. I didn't put that here. We're going to move right 3. And then we are going to go up 4. So our new vertex is going to be 3, 4. Domain for quadratic equations are all real numbers. You can put domain as what x can be, and there's no number in here that's undefined. So you can put in any number for x, and the range, well, let's graph this, and then maybe the range will make a little more sense. So we're going to go over 3, and then we're going to flip over the x-axis, which doesn't do anything when we're sitting right here at 3, 0. And the graph is going to flip, so the graph is going to go down instead of up, but then we're going to go up 4. 1, 2, 3, 4. And it's going to go down, and it's going to go down a little bit steeper. So our range is going to be y is less than or equal to 4. It's always going to be below or above the vertex point for the y point. I wonder, I think I might have graphed this a minute ago. Yeah, here is negative 2 to the x minus 3 squared plus 4. So if I put in 3 for x, 3, 4 is my vertex, and you can see it going down like that. Okay, second problem here is exponential function. Up here in the exponent, we are going to move to the left 5 this time. It's left because to make that equal to 0, we're going to have to put in a negative 5. At least that's the way I like to look at it. Our parent function here is y equals 2 to the x. And that kind of looks like, I'll put a different color in this time. 2 to the x, it's way down here at 0, you're at 1. At negative 1, you're at a half. At 1, you're at 2. 2, you're at 4. So it goes something like this. And it's going to get really close to the x-axis. I didn't put the asymptotes on here. Probably should. But the x and y graph is is your asymptote. And after we shift this thing, you can basically think of the x and y axes getting moved. So we're going to move left 5. We're going to stretch it by a factor of 3. Oh, look at I kept the red pen. Stretch by a factor of 3, and then down 1 for the minus 1 at the end. So this graph is going to go up faster, but we're going to go left 5. So in some ways this point here is 0, 1. We can think of that as going 1, 2, 3, 4, 5, or we can just think of our x and y axis going over 5. So here's our new vertex point, if you will, and then down 1. So if we put a little line in here, that's kind of a big line actually. We're going to put in this graph now moved over, and so you can sort of think of this XY graph as this is our new XY graph. So at 0 we were at 1, so you can go at 1, but since we were we had to go down 1, but we got a factor of 3, so instead of 1 we're at 3, and then we're down 1, so we're actually at negative 5, we're at negative 2, so we're right here. And that's because of that stretch factor, not negative 2. That's because of that stretch factor of 3. So negative 5, positive 2. Negative 5, positive 2 right here. And if you look at the graph, I graphed it here. Here's the graph right here. I'll switch it and then put in a point and put in negative 5 for a point, and negative 5, positive 2. And if I put in negative 10, you can see I'm down at negative 0.9, so I'm really getting close to this graph down here at negative 10. And then it's going to curve up, and then it's going to go up fast. If I put in another point like negative 3, I'm already at 11. So you can see negative 3, I'm already off the graph here. Just, and it goes up really fast. Domain, here again you can use all real numbers because x can be any number. The range is the y can go all the way up to infinity, but it won't go below this new asymptote of negative 1. So y will be greater than negative 1. And it's not equal to negative 1. It will never actually equal negative 1. So on the quiz there will be 2 of these kind of questions, really similar to this, just a little bit different shift. Okay, so now here we don't have to graph them, so it's a little easier. If you look at this formula up here, this is a general form of a transition equation. A is your stretch factor that's out in front of whatever function you're talking about. H is the shift to the right. We do minus h, and that'll shift it to the right. If it's plus, it'll shift it to the left. I like to think of what you need to do to make it equal to 0. And then plus k is going to be your factor that stretches it up or down. So in this first equation, a is equal to negative 3. That's going to stretch it by a factor of 3. And it's going to flip over the x because it's negative. Flip over x. H is 4, so that's going to shift it to the right, 4. Right, 4, and I'm trying to go fast. And then K is 7, so it's going to go up 7. And this is another exponential equation, so really similar to the last one I just graphed. This next one is quadratic, so kind of like the first one we graphed with a parabola. It's positive, so it's going to go up. A is equal to 1/2, so it's actually going to flatten it out. You can still say stretch by a factor of 1/2. But really what it does is it takes a parabola that's like this, and it kind of makes it look more like this. Factor, look at that, change colors on the fly here. H is -4, so we are actually going to go to the left 4. So to me it's always kind of the opposite of what you think. Think of -4 makes this parenthesis equal to 0, and that'll shift us. And then we're going to go -6 for K. So plus K, we're going to go -6, so that's going to go down 6. And that's all we do with these transformations. We either go, we stretch, we flip over on this one with the negative, we go right and left, and we go up and down. Describing words, basically the same exact thing, except that we don't have A, H, and K. First thing in the parentheses, we're going to go right to. We're going to go right to, we're going to stretch 3, or stretch by a factor of 3, but I don't feel like writing that all out, and then up 5. So that's a quadratic with the vertex moved to the right, stretched up, and then up by a factor of 5. Or stretched by a factor of 3 and then raised up 5. This one is a inverse function where it kind of looks like this. And what we're going to do is we're going to flip it because of this -1, and so it's going to be now this graph here gets flipped up, this graph here gets flipped over the x-axis and goes like this. So it changes it from quadrants 1 and 3 to 2 and 4. So what's going to happen? First we're going to move it right 10. Right 10. If it was stretched, this would be a different number other than 1, but it's just 1, so it's just flipped over the x-axis. Flipped over x. Flipped over x, and then up 5. And the last two equations is write the new equation. So we have an exponential equation. Let's go green. And we're going to reflect it over the x-axis, so we're going to have a negative 2 to the x. And then 2 units left, so we're going to go plus 2. That's going to shift that graph 2 units left. And we put that right with the exponent with x. If you do that in your calculator, make sure you put that exponent in parentheses. And then move 4 units down, so -4. Sometimes you'll say write g of x with this new, so our new equation, g of x, which is a transformation of f of x, will look like this. Sometimes you'll see it like this too, f prime of x. And sometimes even you'll see y. Same kind of thing with a quadratic x squared. We're going to shift 3 units right, so that's going to be in parentheses. We're going to do it to the exponents. 3 units to the right, so that'll be -3 squared. Reflected over the x-axis and then vertically stretched by a factor of 1/2. So the 1/2 will get multiplied, and then we'll have a negative 1/2. And I'll go f of a negative 1 of x. Here's our new function. Equals negative 1/2. The negative flips it. 1/2 basically flattens it out or makes it go up slower. And then right 3. And that's it. Have a good one.